So we have a squared b to the minus 2, c to the minus 3, b to the 6th, c to the minus 1, a to the minus 1, divided by this, okay? We have to apply all the laws, all the principles we know from rules of exponents and indices. Number one, we put all the a's, b's, and c's together. So the a's, I brought this a over there, so it's a, b, b, c, c. I put them together. The next thing I did was then to apply the first law of exponents, which is that if they have the same base and they're multiplying one another, we can simply take the exponents and work with the exponents the way they are. So it's supposed to be 2 plus minus 1. But because a plus and a minus are meeting, it becomes 2 minus 1. That's how we get this. We move on to the b. b minus 2 plus 6, which will give us what you see here. And then c minus 3 plus minus 1, which is the same thing as c minus 3 minus 1. That's what we see down here. And then on the bottom, we did the same thing. A to the minus 5, b squared, b to the minus 1, and c to the 4th. All I did was I took the exponent and added or subtracted depending on what we have here. And so all you need to know is when they have the same base, what do I do with the exponents? That's what I want you to know. And that's what I did right here. The next step is then I simplified. So a2 to the minus 1 would simply give me a. b minus 2 plus 6 will simply give me a 4. c minus 3 minus 1 will give me c to the minus 4. Let me just show you something up here. If you look at the problem and it looks complex, always feel free to bring it into smaller pieces. For that problem, you could have simply done it with all the a's, so a2 to the minus 1, and then divided by a to the minus 5. You can simplify this, first of all. If you can simplify that, it means you can do the problem. Because all you need to do is break it into smaller pieces, and then you should be able to handle it. Now, b to the 4th, c to the minus 4, a to the minus 5, b, and c to the 4th. That's what we get after we simplify from this step. Now we move on to deal with the division. So a over a to the minus 5 is the same thing as a to the first power minus minus 5. Whenever you see a letter by itself, a variable, it's basically that letter to just a 1. Okay, so whenever you see a by itself, it's the same thing as a to the first power. Now, according to the second law of indices, or the rules of exponents, we can bring the exponent of the one on the bottom to the top, so that it becomes a to the first power minus minus 5. That's all I did. I brought it up to the top, and that's how I get a to the first power minus minus 5, which is the same thing as 1 plus 6. A minus times a minus is a plus. And then b, I bring up the 1 up to the top, and it becomes b4 minus 1, because this has a 1 as its exponent. And then c to minus 4, and then when we bring this 4 to the top, it becomes minus 4 minus 4, which is c to the negative 8th. According to laws of indices, when we have a number to the power negative something, we can rewrite it. So for example, when we have c to the power negative 8, we can rewrite that as 1 over c to the 8th. And so that's what I did. I brought the c to the 8th to the bottom. And we had a square root sign. But also we remember that when we have the square root of y, for example, it's the same thing as saying y to the power half. That's what I did. I took the half and I put it outside. Now I multiply all the exponents. And now we get a to the power 6 times half, and b to the power 3 times half, and c to the power 8 times half. That's what I did to all the exponents, and that's where I got a to the 3rd, b to the 3 over 2, and c to the 4th. That's how you do this, but you can simplify this answer. One more step, and we can get a to the 3rd, b, and then the square root of b divided by c to the 4th. Some of you will know how I got b square root of b. What happens is that b 3 over 2 is the same thing as the square root of b cubed. But we know that this is the same thing as the square root of b times b times b. But then b times b, we can rewrite this as square root of b times square root of b times square root of b. And this becomes b. The square root of a number times the square root of that same number will give you that number without the square root sign. And so that's how we get b, and then square root of b just comes down the way it is. This is one way you can leave your answer. I would rather have you simplify it to this form. And that's how you do this problem. So we'll stop there for now.